Is there a distant world out there, one that closely resembles Earth, where life could exist, or perhaps even a civilization, waiting to be discovered? The closest star system to our Sun, Proxima Centauri, is home to a fascinating exoplanet known as Proxima b. Though much remains unknown about the planet's true nature, scientists are excited by the possibility that this distant world may harbor the key to one of humanity's most profound questions: are we alone in the universe? The immense vastness of the universe has captivated humanity for centuries, sparking our curiosity and imagination. But beyond the beauty of the stars and galaxies, it's the possibility of finding life on another world that truly ignites our sense of wonder and exploration. At the farthest reaches of our solar system lies a captivating world, Proxima Centauri b, located just 4.2 light-years away. This distant exoplanet orbits Proxima Centauri, the closest star to our Sun, and resides within its star's habitable zone, the region where conditions could allow for the presence of liquid water, a key element for life as we know it. Proxima Centauri b stands out not just because of its proximity to Earth but because it offers a unique opportunity in the search for extraterrestrial life. Its position in the habitable zone of Proxima Centauri means that there is a possibility for liquid water to exist on its surface. And where there's water, the potential for life follows. Scientists speculate that Proxima Centauri b might share many characteristics with our home planet. With a rocky composition and similar size to Earth, it could potentially offer a suitable environment for life, whether that life is microbial or something far more complex. Could this distant world be our best chance at discovering alien life? Imagine what such a discovery would mean. It would radically change our understanding of the universe, and humanity's place within it. But this raises another critical question: how do we get there? The vast distance between Earth and Proxima Centauri b is one of the most daunting challenges of this mission. Even at the speed of light, it would take more than 4 years to reach the planet. Unfortunately, we don't have the technology to travel at light speed, at least not yet. So how do we bridge this vast gap in space? The answer might lie in an innovative and cutting-edge technology that could change the way we think about space travel forever: laser-powered light sails. Imagine small spacecraft equipped with reflective sails, propelled forward by powerful laser beams fired from Earth. These light sails would allow these tiny probes to travel at a significant fraction of the speed of light, potentially reaching Proxima Centauri b within 2 decades. A dramatic reduction in travel time compared to current methods. This is where the concept of pico spacecraft comes into play. Pico spacecraft are small, autonomous probes, each no larger than a grain of rice, capable of journeying across interstellar distances by harnessing the power of light sails. These probes could travel at speeds approaching 20% of the speed of light, making it feasible to explore distant star systems within a human lifetime. But how do light sails actually work? Light sails are thin, reflective materials that can harness the energy of powerful lasers aimed at them from Earth. The laser beams would hit the sails, accelerating them to extraordinary speeds. These tiny spacecraft, traveling at relativistic speeds, could then embark on a journey that takes them across light-years of space. It's an idea that seems almost too futuristic to be real, but laser-powered propulsion could provide the breakthrough humanity needs to explore the farthest reaches of space. However, even with this incredible technology, we face another significant obstacle: the time it takes for signals to travel between us and the probes. At a distance of 4.2 light-years, a signal from the probes would take over 4 years to reach Earth, one way. This delay creates a huge problem when it comes to real-time communication with the spacecraft. It would be impossible to interact with the probes on the fly, sending instructions or altering their course based on immediate data. To overcome this challenge, scientists have come up with a revolutionary idea: pico spacecraft swarms. Rather than relying on a single spacecraft to gather data, scientists propose sending fleets of small, autonomous probes that work together in unison. These tiny probes could coordinate their movements, gather data from multiple locations on Proxima Centauri b, and send back a collective, stronger signal to Earth. This swarm-based approach ensures redundancy. If one probe fails, the others can continue the mission without interruption. By synchronizing their movements and sharing information, the probes can cover more ground, collect more data, and enhance the chances of success. Instead of sending a lone spacecraft that may face technical challenges or failures, the swarm approach offers greater resilience and reliability. The idea of a swarm of tiny spacecraft working together may sound complex, but it provides several key advantages over traditional space exploration methods. Redundancy: if one probe fails, others can continue the mission seamlessly, ensuring that the overall mission doesn't fall short. Coverage: multiple probes allow for a more comprehensive exploration of Proxima Centauri b, enabling scientists to gather data from various locations on the planet's surface, its atmosphere, and even its potential geological features. Strengthens signals: as these probes work together, they can amplify their signals, ensuring a stronger transmission back to Earth. This collective effort helps overcome the challenges posed by distance and weak signal transmission. By operating as a coordinated unit, these PICO spacecraft will create a more potent, reliable network for gathering data, something that a single probe could never achieve alone. Given the immense distance between Earth and Proxima Centauri b, one of the most crucial aspects of this mission will be the autonomy of the PICO spacecraft. With communication delays of several years, it would be impossible to operate the probes remotely from Earth. Instead, these spacecraft must be equipped with advanced AI systems that allow them to make decisions independently, based on the data they collect. These autonomous systems will ensure that the probes can continue their mission without waiting for instructions from Earth. They will prioritize data collection, make necessary adjustments to their trajectory, and even determine what scientific measurements are most important at any given time. This autonomous functionality allows the mission to proceed smoothly, even if communication with Earth is delayed or lost altogether. Once the probes reach Proxima Centauri b, their primary mission will be to search for signs of life. This could involve detecting biosignatures, or chemical markers, that suggest biological activity. The spacecraft will analyze the planet's atmosphere for traces of oxygen, methane, and other organic compounds, substances that are often associated with life here on Earth. Finding these markers would be a game changer, as it could point to the existence of life on Proxima Centauri b. Beyond the search for life, the probes will also gather critical information about the planet's geological composition, surface conditions, and climate. Understanding whether Proxima Centauri b has ever had environments conducive to life could provide us with clues about how life might evolve on other planets. Moreover, by studying the planet's geology, scientists hope to gain insights into the broader processes that govern planetary formation, and how such processes might apply to other worlds in the galaxy. As we venture further into the cosmos, ethical questions surrounding space exploration become more pressing. One major concern is the potential for contamination, the risk that we might unintentionally introduce Earth-based microorganisms to an alien ecosystem. Even if no life currently exists on Proxima Centauri b, the risk of contaminating a planet with our bacteria or viruses is a real and serious ethical dilemma. How do we balance the drive for discovery with the moral responsibility to protect alien worlds from harm? Another ethical issue revolves around the question of ownership. Who owns the discoveries made on other planets? Should the nations or organizations that fund the mission claim ownership of the new knowledge or resources, or should it be shared for the benefit of all humanity? The issue of ownership could extend to any potential resources found on the planet. Should they be exploited, or should they remain untouched? These ethical questions highlight the importance of careful consideration before embarking on such a monumental mission. This mission, with all its technological breakthroughs and ethical complexities, represents more than just a scientific venture. It embodies humanity's insatiable curiosity and our drive to explore the unknown. The search for life on Proxima Centauri b is not just about discovering alien organisms, it's about understanding our place in the universe and unlocking the secrets of existence itself. Whether this mission succeeds or fails, it will pave the way for future explorers. It challenges us to think beyond what we believe is possible, and motivates the next generation of scientists, engineers, and dreamers to continue the pursuit of knowledge. With Pico spacecraft, swarms and